All right, let's work on number 3. We got a hot air balloon blowing up. And it says the radius is in feet, modeled by a twice differential function, r of t, where t is in minutes. They tell you that r is concave down. The table gives selected values of the rate of change of r of t. Okay, so think about that. So r of t is the radius at any time, right? And so r prime of t is the rate of change of the radius at any time. And it says the radius of the balloon is 30 feet when t equals 5. And then it gives you a volume. It says estimate the radius of the balloon when t is 5.4 using a tangent line approximation at t equals 5. So remember, and I'm going to use r of t. If you did y's, that's fine as well. But I'm just saying r of t is the radius. So this right here, I just want to make sure you understand r of t is the radius at any time. You don't have to write that down. I'm just saying it. Okay. What you do have to write down is I'd say this. Well, they tell you that r of 5 is equal to 30. So your point is 5, 30. Now, if I'm doing a tangent line at 5, that means I'm going to look at my chart right here. R prime of 5, the rate of change at 5 is 2. So my line, and again, you probably didn't use r's, and that's okay. I'm going to go to y's even, because that's probably how most of you did it. You would do y minus 30 is equal to a slope of 2, x minus 5. That's what you did, but you have to understand that, again, y is like r and x is like t. So, and you can do it with r's and t's as well. So r at 5.4, I'm going to pop that 30 over, and that would be my y value. Do you understand that r at 5.4 is approximately 30 plus 2 times 5.4 minus 5. Now, honestly, I'd stop right there. You don't have to do any more. I'm going to give you the number. If you got the number, it is 30.8. But remember, once you get it down to that, you could stop, but label feet. So I would get that. That is that part. Then it says, is your approximation greater than or less than the true value? So I would say approximation is, and I'm using wording that they did, is greater than true value, since why? True value, since what? What does a tangent line approximation, what does it have to do with? What do you need to say? It has to do with r being concave up or concave down. Y'all, that was given. That was given. So you can just state it. Since r is concave down. Tangent line approximations have to do with r being concave down. And if you said r double prime is negative, here's the thing. You need to speak of concavity. Now, if you're having to prove it's concave down, then yes, you would show the second derivative, show that it was negative. But this one was given, so you can just state it. So what are the points? You got 1 point for getting this answer. Again, where you leave it is your call. But remember, if you have this line and then mess up in the math and have this, they grade your final answer. So that's why I'm saying learn when to stop. So did you get the approximation right? And then 1 point was for saying that the approximation would be greater than with a correct justification. Okay, r is concave down. All right, so what's in pink is what I would write, and I'll kind of keep that consistent throughout doing this. Find the rate of change of the volume of the balloon with respect to time at t. Indicate units of measure. Oh, good old related rates that they threw in. The rate of change of the volume. Now remember, the given information was that volume was 4/3 pi r cubed. So it says find the rate of change of the volume of the balloon. So dv dt, I'm going to take the derivative with respect to time. When I bring that 3 to the front, I'm going to go ahead and reduce as I go. It makes my number smaller. R squared dr dt. You got to remember that dr dt. And then that's when I go plug in. So I have 4 pi. What's my r? Well, at 5, remember time is 5. They said the radius was 30 there. So 30 squared dr dt. What is dr dt? It's the rate of change of the radius at that time. And for the same reason, I'm looking right here. That number is 2. So I'll plug in a 2 there, and I will get dv dt. Now, here's where a couple things. I'm done. I would stop right there because once again, I get full credit for that. If that's going to be my final answer, I have to write dv dt evaluated at t equals 5. That is so important that you have that notation. And then I would put feet. What are the units of measure? Well, the units of measure, what is volume measured in? That would be feet cubed. And what is the time measurement in this problem? Minutes. So it would be feet cubed per minute. Just FYI, the actual number, if you got the actual number, if you simplified, you better have gotten down to 7,200 pi. And how sad that some people put 7,200 and forgot the pi and didn't get the answer point. So again, that's why I like stopping right here as long as I label. Well, I'll go ahead and do the points on this one. And you'll just, there's a part that's in part C as well. But okay, so here are the points. In this line, doing this derivative with respect to time was 2 points. So it's kind of like if you put dv dt and you forgot the dr dt, I gave you 1 out of the 2. So that, or if you made a mistake, I could give 1 point. If you knew to take the derivative of volume and something was right, I could give you maybe 1 point. If there was a ton of mistakes, then I could give you none. And then the second point, or I guess third technically, was getting the correct number. So whether you stopped here, which I would, +1, or getting to the 7,200 pi, that's another point. Now let me do part C because there's another point there, but let me do part C first. Use a right Riemann sum with 5 subintervals indicated by the data in the table to approximate that integral. So notice that R prime is what is on the table. So it's saying to approximate 0 to 12 of these numbers. And it said 5 subintervals, which makes sense because I have 5 different, if I were to draw it out, I would have 5 different rectangles there. These would be my widths of the rectangle. It says a right Riemann sum. So basically my numbers are coming from 2 times 4 plus 3 times 2, 2 times 1.2. That's where my numbers are coming from. I'm using the 5 rightmost. So these are my widths, these are my heights, and I'm going to write that out because they like me to. 2 times 4, base times height, and on down the line. Now, once, y'all, this was so sad in grading your papers. People had that, and then they didn't get the point because they added that all up. Stop. Feet. Done. Let it go. You don't have to do more math. Now, you can approximate that number and go, okay, does it make sense? I mean, 8 plus 6 plus 2.4. I mean, I'm not saying the numbers are difficult. And if you added it up and got to 19.3, okay. But what I'm saying is, in the point count, if you have that listed and you add up incorrectly, you will not get that point. And it was 1 point for the approximation. So that just breaks my heart that you were doing it right, but don't get the point. Now, using correct units, explain the meaning of this. Y'all, in terms of the radius of the balloon, if you're explaining the meaning, don't be mathy. That's coming from a math teacher, but don't be mathy. Talk like a normal human. Okay, what's going on? What is this? It's. I would say it this way: from 0 to 12 minutes, specific time, the radius of the balloon grows or expands or something by 19.3 feet. Done. Done. That's a normal human can understand that. From 0 to 12 minutes, the radius of the balloon grows by 19.3 feet. Now, if you say, well, if I didn't get that number, what should I, do? That's fine. From 0 to 12 minutes, the radius of the balloon grows by, you can write that out again, or grows by this amount in feet or something like that, by the answer in feet, or I wouldn't say that. I don't like that. So you don't have to get the number, but it just, I'm saying you talk like a normal person. I don't like, and I saw in grading, I saw a lot of like on 0 to 12, like you had like mathematical notation. You shouldn't have mathematical notation. It should be a sentence that you're writing. Now, some people said the total amount of the radius is 19.3. You don't know that. What if somebody walked up as they were blowing up the balloon already? You don't know that the radius at 0 was 0. So remember, the integral accumulates the change. That's why the words grows or expanded by that much in that time. That was the important word there. Now, what are the points? You got 1 point for this approximation, and you got 1 point for this explanation. Then there was a point, as I graded this, then I looked. There was a units point on B and C being in feet. So it was B and C. Now remember, they don't give half points. So if you, unfortunately, didn't do part B, you couldn't earn that unit point. That's why I'm always saying, look, if you don't know how to do it, write some numbers down and put a unit on it, especially when they say indicate units of measure, then probably a units point is out there. So you'll want to get that. So you have that point. And then finally, the last one, is your approximation in C greater than or less than? Give reason for your answer. I would say, okay, what does it come down to? What does a Riemann sum, what is that based on? A Riemann sum being an overestimate is an increasing or decreasing. Now, I was estimating R prime of T. So I have to talk about R prime. What is R prime doing? Is R prime increasing or decreasing? Well, that wasn't given to me. And just looking, what do I know? Well, here's this curve sketching relationships. Let's think about this. If R is concave down, I'm kind of going a roundabout way, but if R is concave down, then the second derivative, R double prime, would have to be negative, but I can't say that. That doesn't matter because I have to defend with what I'm doing. R prime would be decreasing. So I'm going to say it like this. Since R is concave down, R prime is decreasing. So a right Riemann sum, I spelled Riemann sum wrong, will give, I'm making this very wordy, a value less than the actual value. Now, I made that very wordy. I don't know why I wrote it so wordy. But since R is concave down, R prime is decreasing. Therefore, approximation, I don't know, approximation is less than this. And you're saying, why don't you just say an underestimate? I try to use wording from the problem. So if they say, is it an over or underestimate, then I use those words. In both of these, they said, is the approximation greater than or less than? So I try to use those words. I think you'd get credit. I just am in a habit of using the wording from the problem. And then my answer is very, I definitely answer the question that was asked. This problem was worth, or question was only worth 1, but a key component of it is if you said, I said it was an underestimate, you had to say that R prime was decreasing. That was the key thing that I was looking for, because, and if you just say since R is concave down, you didn't get credit. You had to say R prime is decreasing. Now I would add that in because sometimes they're like, how did you know R prime is decreasing? So always from the given, they told me R was concave down. So it's just making sure that you say everything that you need to say. And there are your 9 points. I will tell you the average on this guy. Oh, come on, guys. The average on this bad boy was 2.48. Come on. You can get 2.48. Shoot, you can get a lot more than that. And a lot of you did. So you did a great job. 1, 2, 3, 4, 5, 6, 7, 8, 9 points. Some of you got all 9 on those. So good job. All right. All right.